Hi guys, today we want to talk about the generative adversarial networks, or GANs in short. The GANs first introduced in 2014 by the Goodfellow and his colleagues. I think the GANs is one of the most creative algorithms in the field of deep learning. GANs consist two submodels, the generator and the discriminator, and we will talk about them in the following. But first, I think it's better to take a brief look at the structure of an image. Imagine we have two pictures. First one is the pictures of a number and the second one is a picture of a man. But how the computer can understand and distinguish between these two pictures? The answer relies on the patterns. As you know, all the picture consists some pixels ranging between 0 to 255. 0 means completely black and 255 means completely white. And all other numbers are placed between these two numbers. As you can see, the patterns of these two pictures are different, and the computer can understand and distinguish between these patterns. So the computers can change the image, the initial image, to the number of tensors, the ordered number of tensors. So now the computer can understand these patterns. What I mean by pattern is not only about the number placed together alongside, but also the color, texture, line, smooth or sharp, or so forth. So as a summary, the computer cannot understand the images itself, but it can change it to a tensors, and then from the tensors can understand the patterns. I mean, can understand the features, the colors, the lines, and so forth. So let's back to the GANs. The goal of GANs is to create fake images that resemble the real one. But how the GANs can do this? The generator's job is to create fake image. We can imagine a generator as a function that has inputs and outputs. The input of generator is a vector, we called it Z here, or we call it noise. The noise is randomly created vectors from normal distributions or Gaussian distributions, and these vectors pass through the generator. We don't want to talk about the structure of generator now, but the generator, most of the generators use CNN, convolutional neural network, to process the noise, and then the output of the generator is a fake image. The output of generator, I mean fake image, should be the input of discriminator. And the discriminator wants to recognize this is a real image or fake. But how the discriminator can understand this? It needs a criteria. So the real images, I mean our data set that we have created before, is a criteria for discriminator to compare these real image and fake image and decide this is a fake image or not. The discriminator can understand, can learn the feature of real images and can learn the fake images features and then compare them, and the output of the discriminator is real or fake. The output of discriminator is revealed to generator. If the discriminator can understand this is a fake image, the generator tries to update itself, enhance itself through a self-enhancement process and try to fool the discriminator. But in the initial steps, the discriminator can easily understand it's a fake image, but through many iterations, the discriminator cannot distinguish between the real image and fake image, and the generator can fool the discriminator and even fool us as a human, and we cannot understand this is a real image or fake image. This is the structure of GANs. In this video, we didn't talk about generator and discriminator in details, but in future videos we'll talk about them. So if you have any question, please drop me a line below this video, and have a nice time. Goodbye for now.